Hello everyone, welcome once again to this series of lecture video on unsupervised learning. My name is Priscilla Chamenyi. I am a junior data scientist for global communities in the Laboratory of Data Science. In this video, we'll be looking at affinity propagation. So, affinity propagation is a clustering algorithm used to cluster data points into multiple groups based on their similarity. It does not require the number of clusters to be specified beforehand. It iteratively adjusts the responsibilities and availabilities between data points to determine the number of clusters and the assignment of data points to those clusters. We'll be explaining the terms responsibilities and availabilities shortly. So now we're going to take a look at how the method works. Each data point can act as an exemplar, that's a representative of its own cluster. Each data point can also have a preference for being the exemplar of other data points. Each data point has a preference score indicating how likely it is to be an exemplar or representative. Preference scores can be set uniformly or based on prior knowledge. The algorithm seeks to find the set of exemplars that results in the highest total preference among all data points. The algorithm. So we provide a similarity matrix where each element represents the similarity between pairs of data points. Now, responsibility measures how suitable a data point is to serve as an exemplar for another, and availability measures how appropriate it would be for a point to choose another point as its exemplar. In the algorithm, the responsibility and availability messages are updated iteratively to refine the exemplars. The algorithm stops when messages stabilize, indicating that the exemplars and clusters are identified. Data points are assigned to clusters based on the final responsibility and availability messages, centered around the identifiers exemplars. The advantages of this algorithm is that it is suitable for clustering data with complex relationships and nonlinear structures. There is no need to specify the number of clusters in advance, offering greater flexibility. It is also capable of producing high-quality clusters, even with varying densities and sizes of data points. And lastly, it is applicable in diverse fields such as image segmentation, customer segmentation, and gene expression analysis. Some disadvantages of this algorithm is that it is computationally expensive, and the choice of similarity metrics significantly impacts performance, hence requiring careful selection. Another disadvantage is that it may not always outperform other clustering algorithms like k-means or GMMs in terms of results. And the last disadvantage is that it may produce multiple exemplars for a single cluster, complicating the interpretation of clustering outcomes. Here is a code in R using the affinity propagation method. The data set used here is the iris data set in R. Each data point representing an iris flower. The features are sepal length, sepal width, petal length, and petal width, all in centimeters, which are also the 4 numerical features. And the 1 categorical feature is the species of the flower. This is the output after implementing the algorithm on the data set. We have a length of 6, which is the AP results object containing 6 key components storing various outputs of the affinity propagation algorithm. And the class AP results is tailored for holding and processing the results of affinity propagation. This brings us to the end of today's video. This work is brought to you by the Laboratory of Data Science and the Indiana Data Mine Grant, and it is supervised by Professor Alessandro Selvitella. Until we meet again, bye and thank you for your time.